Hi guys, welcome to another Learn Electronics Repair video. This is from Handy Andy at the phone repair shop. He just brings me some strange things to repair really, but if he wants to pay to have them fixed, I'll try to fix them. So this is a satellite receiver, digital satellite receiver, HDT Hyundai digital technology, and he says it has a power supply problem. Oh, it has something rattling inside it. I mean, this is how it came to me, yeah, so the lid isn't on and something's what's loose in here? I think it's down in the front, you know. It's that old rubber pad, that's not what's rattling around. Oh, okay. So here we have a case screw, most likely. Oh, something else. Oh, hold on. Yeah. Here we have another of the same. Come on. Get that out of there. Okay. Another of the same. Oh, there's more. There's more in this thing. They've got me down in the front. I can't see them. Okay. Third of the same. That kind of like fell out. No, I think maybe there isn't anything. Let me just. Not sure, you know, if there's still something. Oh, there you go. Definitely still something. Let's see if we can persuade that to come out. Fourth of the same. I was like pulling teeth there, isn't it? And now nothing rattles. Good. He says this has a power supply problem. So, well, we have a power supply. That's the first thing. And we just have one big circuit board as the second thing. No doubt a little display on the front as well. So, let's see. I'll move out the way. Let's see what we've got. I think I'll connect this to the light bulb, the current limiter, and just plug it in and see what happens. Yeah, I think that's what we'll do. We've got an on-off switch on the back. So let's get the camera ready. Let's have a look to see what's happening. The current limiter, the light bulb, was up here. I'll show you guys how to build one of these days. So we'll switch it off on the back. We'll plug it in, and then you would expect the light to kind of like flash fairly bright and then go off. Obviously the camera moved. Let's see what's staying in shot. So let's switch it on and see what it actually does. Well, it does nothing, which suggests that this is not drawing any power at all. So it does nothing. Try this. Oh, you know what? It does something. It's got like, can you see it? Very dimly in here, like 3 dashes lit up, yeah. So it is drawing power, it's just drawing so little power that it doesn't light the bulb up. Oh, you see, let's switch it to normal mains now. Something there. So let's switch it off. Now let's switch it back on again. Yeah, you see it? So something's lighting up dim on the front, so it does something. So again, we've got something we don't really know anything much about, and we're supposed to fix it. So let's have a look to see what we have. First of all, let's have a look at the power supply. So we have obviously mains coming in at the back. It's actually plugged in at the moment, so I've unplugged it from the mains, although it was switched off on the switch, but I've actually now unplugged it. Looks like it goes through some filter on the mains, the fuse, which I think we can assume the fuse is good because something's happening. But let's not leave any stones unturned, yeah? I've put the meter where you can see it. I'm on ohms range. So we'll check this fuse, but I'm pretty sure this must be okay. Yeah, fuse is okay. So because some power is getting in. Next thing I'd be interested to see is, are there any bad capacitors on the power supply before we look at anything else? So there's one here. I mean, I'm looking for visibly bad capacitors. This one might be. Might just be some dust and crap on the top of it, but it might be a bad capacitor. Let's just, yeah, this one has like signs as like something might have leaked out of it, possibly. All the rest look basically okay. I mean, I have a power cable coming from here, going to the main board, and another whole bunch of capacitors which sort of look visibly okay. There's lots and lots of them in here. But I don't think any of them actually look like they're bad, so I'm moving the camera slightly while I'm doing this. Let's have a look. So move that out the way slightly. Let's have a look. Yeah, so we're down this side. So yeah, they look sort of all right. Looks like there's another voltage regulator here. It says REG3. This is probably a voltage regulator or something similar, a MOSFET maybe. Possibly that's to do with powering the tuner. Just a guess. I don't see any buck regulators on here. I don't see any coils or maybe buck regulators. So I'm guessing this power supply actually generates all the voltages the main board needs, apart from maybe what comes on this one here, Reg 3, and possibly that. So let's have a look. I think we'll switch this back on again and see if we can figure out which of these is ground. And we can do that by just measuring the resistance from chassis to the connector. I'm pretty sure we'll find. Well, that's not ground. The black one isn't ground. I've got a good ground. Let's have a look, see if we can see. And while I'm doing this, we might spot any shorts as well. Well, that looks like a ground. That doesn't. There's a bit of voltage in the capacitor, then some negative resistances. Okay. Don't see any shorts. That is possibly a ground. I mean, obviously, one of these that reads like ground could be a short. I'll keep that in mind. Then another one. So there's three that actually read connected to ground. I mean, I'd probably have to. Well, we can disconnect the other end. We can unplug this end, and we can look again just out of interest. See if we still see three that are connecting to ground. So we have. I think this was one of them, and it's still connecting to ground. That now reads open. Well, so that had some sort of load on it. That connects to ground. That's two. Okay. There was a third one somewhere down here. That one. So I still have three connected to ground, which suggests if there isn't some sort of short on the power supply, then they are ground. And to be quite honest, if there was some sort of short on the power supply, some sort of short, I'd expect it not to run at all or blow the fuse or something. Let's have a look. So we can see we have 1, 2, 3 big diodes here, which are going to be power rails. That's 3 voltages. Possibly this one's a I haven't seen. Could be a voltage regulator. Same with this one. They're marked U3 and U4, so they're unlikely to be transistors. They're more likely to be ICs, where it says they're more likely to be regulators. I'll switch this on. Still keep this in mind. I'll switch this on and let's have a look to see what voltages we've got on this. I mean, there's nothing marked, unfortunately, on either end. Unless we're lucky and there's something marked underneath. But let's have a look to see if at least we can see what looks like reasonable voltages here. So I'll plug it back in. Switch it back on. Yeah, a little dim display. Let's see what we actually have. So we know the top one was ground. I've still got this unplugged, by the way. Might have interest. Well, nothing on there. Nothing on there. 27 volts. Make that, get rid of the there. 27 volts. 20 volts. 12 volts. 7.75. Nothing. I think that was ground. 5. 3. And 5. So we've got 3, 5, 7. And some high ones, 20 something, and a 12. Doesn't look too unreasonable. Switch it back off again. I'll just give it a few seconds for the capacitors to discharge, and then I'll reconnect this and we'll check again to see what we can see. I've connected the main PCB back up again, and I've just marked on here the 3 connections that read 0 ohms to ground. So we can switch this on, and let's have another loop just to see what we have. So put it back into a volts range, so that would be a handy thing to do. We have, starting from here with the black one, so we have a 5 volt supply, we have a 2.6 volt supply, we have another 5 volt supply, next one is ground, then we have a 6 volt supply, so it's really slightly different when it's connected to the board, the 12 volt supply, and the 22 volt supply, and the 30 volt supply. Is this on 30 as well? So this one appears to have nothing on it, but doesn't connect to ground. So I'm interested to see where that goes to. All the rest, I think we can probably assume they're probably okay. I mean, this one, 2.7 seems a little bit strange, you know, but I mean, 5. I'm sure one of these read 3.3 before. I was connected to the other end, 12, 22, 30. Yeah, that 2.7 looks a little bit strange as well. I think that maybe should be a 3.3. So the versions we can do is take this PCB out. I've switched it off again. Look at this capacitor because it looked a little bit ropey. And let's have a look to see where this pin is going to and whether that somehow should have a voltage supply on. The other thing that I think about this is that I can only see one transformer, one big, well, it's a chip actually, an IC that's driving the power supply. I don't see like a standby and a main supply, but this thing has like a standby button on the front, which you'd assume is enabling something on here. Oh yeah, maybe that, maybe this one that had like no voltage on, or one of these, maybe the 2.7, is actually the enable pin, because you think about it, there's an enable here, and that may be enabling something on the power supply, but the fact there's only one transformer makes me think that might not be the case. That this might always be powered up basically, and the standby switch actually enables something on the main board. Just before I take this circuit board out, I'll just make sure there's no voltage in the main capacitor, and I can see here there's no PFC circuit on this. This is just a bridge rectifier made of 4 discrete diodes connecting to the capacitor. So if we connect between the positive, I'll just do it this way, the 2 stripes, this is the positive end and this is the negative end where the 2 blacks are together, well, blanks if you like, there's no stripe. So there's no voltage in the capacitor now, it has discharged. So let's take this apart and let's have a look to see what's going on. Before I disconnect this, even though the switch is switched off, I'm just going to actually disconnect this from the mains as well, just to be absolutely safe. Now let's get it apart. Okay, we can look at the other side of the board now. There's no markings on it again, but it does tell us a few more things. So we can see where I marked the ground. So it was the end one and the second one. Sorry, end one and the third one in, sorry, and then the fourth one from this end. So you can see the end one is connecting to ground. This is all ground, it goes to the screw. And the second one also connects to ground, and then 1, 2, 3, fourth one also connects to ground. So they're all connecting to ground. Then we have 1, 2, 3, 4, 5, 6, 7 voltage outputs, I would say, all coming from, you know, different places. And then this one, the one that doesn't have any voltage on it, if you look, it goes to this pad here, which seems to have nothing soldered in. And if we look on the other side, it's actually going to here, which is a component that isn't fitted. So the fact we have no voltage on this now seems quite reasonable, which makes me think this power supply is probably working okay. I mean, the voltage I see, I mean, the 2.7 seems to be slightly odd, but all the other voltages sort of looked okay. And it's going to be a bit hard to determine that one that reads 2.7. Maybe we can track it to where it's going. If we can clearly see, for instance, it goes to a 3.3 volt regulator, we'll know that's wrong. This one here, I've just got the dust off it, KA7812, so that's a 12 volt regulator. So we've definitely got a 12 volt supply on here. This one, can we see it? If I just get down there again, looks like a volt for anti. Oh, this is a MOSFET. I think it's a bit hard to see. I'm going to have to get the magnifying actually have a look to see what that actually is. Just one moment, I'll tell you what that is. That one is actually a Fairchild, I think that little symbol is, and it's 27BR33, which makes me think that is probably a 3.3 volt regulator, which is kind of interesting. Because we seem to have 3.3, well, we did have 3.3 on here somewhere until I pulled it to the board. Then we had 2.7. So I'm interested to see where that connects. But first of all, let's just find a data sheet for this. So this 27BR33 and see what it actually is. So we have 27BR33. I think that was a markings. It's a little bit hard to read. Let's see if we can find that. Yeah, 27BR33. Is that a 3.3 volt regulator? Oh, first of all, it doesn't actually find it. Let me see if I can actually find it. Yeah, maybe this is it. FSC is a make. 27BR33. Can we find any datasheet for it? Yeah, okay, I can't find a datasheet for that device, but I think it's very likely that's a 3.3 volt regulator. And we can have a look, so we can see where it's connected. So we have, this is the device, 4 pins. And one pin I'm guessing was going to be ground, most likely. Let's have a look. Not that one. No, that pin's ground. This pin appears to be going where we were interested in, so it comes across here to this link. That's just a wire link. Yeah, it's a wire link there, J7. And then it goes to the second pin in here, which is the second one up. So if that's the one that was reading 2.7, I don't just quite recall which one it was now, that might be saying there's something wrong with this. The other thing I'll notice with this is that we have something wired here. Is this end ground? Let's have a look. I wouldn't be surprised. Yeah, ends ground. I bet this is a capacitor. So, yeah, we have this little capacitor here as well on the output of this. Now, it's not unusual for voltage regulators not to work properly if the output capacitor is faulty. So, we do have some things we can look at this. I'm going to check this capacitor. I'm going to check out this one that just looks a little bit corroded. And now let's power this up again and let's have a look to see what is happening to the output of this device. And if this is going to where the 2.7 is when we have a load connected, but it's 3.3 when we don't have a load connected, I think that's something we need to look into. Okay, so first of all, let's look at this capacitor. So the usual thing then, a little bit of flux, probably just make it a bit easier, although this is going to be quite easy to get out of here. flux on. Let's get a bit of leaded solder onto it. Okay. And then we can just take the capacitor out basically. We can see that it's not marked on the PCB, but we can see that the stripe is at this end, which is where I actually measured was going to ground, which made a lot of sense anyway. So let's just warm it up and pull it out. You probably heard the little creak as it came. Yeah. Okay, so there's our capacitor removed. While we're at it, we might as well just clean up the solder as well. As good a reason as any, as it makes it easier for you to see where to put the thing back. But thinking, well, where exactly did I take that from? Yeah. So let's have a just clean that off there. Clean this off here. Let's look at this capacitor now. Let's look at the other one that looked a little bit distressed. So this one's a 100 microfarad 10 volt. Let's get the capacitance meter and the ESR meter and see how it reads. Yeah, I mean, you know, but it's not a low ESR capacitor. It's saying that's good if it's less than 47. Ah, but it's 100 mic, so maybe that isn't good, you know. Maybe this is not good. Just switch that off. Let's have a look on the capacitance meter and see what it reads. Okay, so here's the capacitance meter. Very nice little tool to have, this one. They're not expensive and they're well worth it, even if you've got capacitance range on your multimeter, which I have on mine, but I still have one of these. What's it reading? Oh, you know, it reads a bit low, but I don't think it's reading low enough to stop this from working. In actual fact, I think it's probably okay. But while we're at it, let's just replace this. So it's a 10 volt 100 microfarad. I'm sure I can find some salvaged one that'll work here. Okay guys, I found just a salvaged one. This is a 16 volt 100 microfarads, but that'll be fine. Let's just see what the ESR meter thinks of this one. So we can check it. Yeah, 0.515, and now it's saying it's good if the capacitor is less than 200, which it is. So that's telling me it's a good capacitor. Is the capacitance meter now telling me it actually reads a little bit higher than its stated value, which it should do normally for a good one? Okay, let's try it. A good contact on it. You know, this is reading exactly, actually. I'll take the 100, that's always been exactly, yeah. So let's try this one. That close enough, I think so. We'll put this capacitor in, and as I mentioned while we're here, let's have a look at the other one, the one that actually looks a bit ropey. So that one's over here. Again, I should just be able to get this to come out. Might need to add a bit of solder to do it, but we can try. So it looks like the capacitor is from here, yeah, and the other end is here. Not wanting to move easily. I think I actually had my finger on the wrong capacitor actually. Yep, it's coming. You can hear it creaking, yeah. So I'm just effectively warming up one end and then pushing the capacitor in the opposite direction. Yeah, you see I've moved it to one side, yeah. Let's go again. And this should now come out quite easily, I would think. In fact, it's almost out actually. Oh, a bit difficult to get hold of actually. Yeah, okay. Again, we'll just clean this up, ready to put the capacitor back in. Let's just a bit of leaded solder, a bit of solder braid. Okay, a bit more solder braid. A bit more again, solder braid. That's it. Could use a vacuum pump on this if you want to do. Okay, so this is our other one. It probably actually doesn't look so bad now, but let's just check it. So it's a 470 microfarad 10 volt. Again, we'll go with the ESR negative. Let's just switch it on. Yes, I'm reading quite low. Well, he said it's good if it's less than 470, it's a 470. Okay. Let's have a look what it reads on the capacitance meter. Oops, wrong one. Capacitance meter. Okay. I mean, I might as well change it anyway as soon as I've taken it out. Okay, so negative. It's reading a little bit lower again. I'll change it, but again, I don't think that's enough to cause a problem. I've noticed actually now the battery light's flashing on my meter. It's reading 440. Let's change the battery in the meter as well. I mean, they've been in here for many years, I think, the ones that are in at the moment. Okay, let's check again. Always keep some batteries in, guys. You'll never know when your test meter's going to go up the ghost like that. Yeah. Reading a little bit under, but it seems to be okay, especially the ESR looks good on that one. So let's give that a go. As I said, I don't think the one that I took out, honestly, was bad enough or even bad really to make any difference with it. But, well, we're here now, so we might as well, yes. Okay, there we go. I'll just put this back in place here. That's done. So let's power this up again. I've just disconnected it from the main circuit board one more time. And let's have a look to see this 3.3 volt supply that we were interested in. So just switch it on. Just have to plug it in actually, then we can switch it on. Let's find the mains plug. Okay, it's in and it's on. So let's have a look. So I think it was this second one in. It's reading 3.3. It's actually on this track here, I believe. Yeah, 3.3. So that comes from this device. We know that. So again, we'll switch it off and let's see whether we now still have 3.3 on this pin. So I'm sure it went to 2.7 before. I'll just give it a moment while all the capacitors discharge, and then we can. Yeah, let's plug it in. We're back on again. Now what have we got? 2.6. That seems strange. This has 4 legs on this device. I'm thinking it's got a ground, which we know it's got a ground. It's got a voltage output. It's got a voltage input, and then the other one's probably an enable pin. Now that's my guess. Seems a bit strange that we only have 2.7. I can't imagine this is drawing a lot of current. I mean, if it was drawing a lot of current to drag that voltage down, then we can assume this would actually get warm. Yeah, this thing, it would actually warm up. I mean, it's obviously bolted to a heat sink, so it does generate some heat. Let's switch it on again. Yeah, nothing's happening. Is this getting warm? No. So is it something to do with this 4th pin, which kind of like it's in standby, then somehow it gets enabled, and this goes up? We still have the same thing. The red light's lit now. I'm not sure if that was lit before, and this kind of like a dim display. That's a little bit odd, guys. Let's see if we can work it out. So we know we have voltages. 5, that looks good. The questionable one. 5, so we've got 5 volt supplies, that looks good. 6 volts, maybe. 12 volts, that makes sense. Then these higher voltage ones are not unusual for a satellite receiver. The tuner which powers the LNB on the satellite dish sends power to the LNB, and it normally will switch between horizontal and vertical signals by changing the power between 12 volts and 18 volts. So having a supply like 20 volts or something is not at all unusual on the satellite receiver. So 22, that doesn't seem particularly strange. 30, yeah, I mean, I don't know why you'd have one quite so high. And this is the one we've proved doesn't actually go to anywhere. So all the voltages seem to be present apart from this. This one was, oh, in fact it's increased now. There's something strange here, guys, with this, without a doubt. That isn't getting warm. There's no warmth in it. Interesting. Why would that regulator not give the correct output voltage? And why can't I find a data sheet for it, which would be rather handy? See, it's gradually climbing up. Strange. The next thing I guess I'm interested in, and back on here again, is let's see if we can figure out what the pins on this device are doing. We know where the output comes. We know there's ground. I'm pretty sure the input probably comes through this inductor. I wouldn't be surprised, off this capacitor. So we need to see what voltage input it has. Let's see if I can actually... I've got it switched off now. I've unplugged it from the mains. Let's see if we can get a contact onto this inductor here. Can we find an input pin? Otherwise, we'll just have to take it back out and have a look. There's something there. Okay, so I can't exactly find an input pin. So let's have a look to see where this voltage supply actually does come from. Well, this is the device. We know that this pin goes to our 30.3 volt supposedly supply. Yeah, so we know that goes to there. So this end pin, that goes off here somewhere. Yeah, through this thing. That's like a wire link. Oh, that goes to the other capacitor that we changed. That's interesting. And it goes to the positive of the other capacitor we changed, which then goes through this inductor here. Yeah, this inductor here. So from here down to the pin 4 on here, we have a connection, and then this goes, looks like, yeah, another capacitor here, and then it comes from this rectifier diode here. So that's where the supply comes from, and we can assume that must be more than, well, more than the 3.3, that's for sure. So we can say that's the voltage in, goes to there, so we can measure that. This one's voltage out, so this one I think is ground. We'll soon find out. Yeah, that goes to ground. And where's the fourth one go? Well, that actually reads like a voltage on it. So there's some charge and some capacitor somewhere. I'm reading resistance, but no, that's like a high resistance to ground. It's just decreasing, but so that's a high resistance. That goes to, looks like it goes to here. No, that goes to here. But again, through a fairly 4.7k. Yeah, there's a resistor down there that's dusty, but I think that is actually a 4.7k resistor. Yeah, you can see it clearly now. Yellow, purple, red. So that's a 4.7k resistor. Then the other end of this resistor, I'm guessing is holding it to a voltage rail, like holding it high. So have a quick look, see where it goes. So that's the resistor. This is the other end. Goes to, oh, I see. Yeah. So basically, the voltage coming in goes to a 4.7k resistor to the fourth pin. So I think we can actually just draw this now, so we know what we've actually got here. We have our 3.3 volt regulator. We know it's a 3.3 volt regulator here, which actually has 4 pins. The first pin, so we'll call this pin 1. I'm sure this is pin 1 at this end. 1, 2, 3, 4. So pin 1 is the input, okay, and that is going to V in. A bit messy, but that is the V in, and we know there's a capacitor from here to ground, and it goes through a wire link here and there. This pin, the next pin, pin 2, actually from this end, yeah, that's the output. Okay, so from pin 2 we have to out, which should be 3.3 volts, and again we have a capacitor to ground, and these happen to be the two capacitors we changed in actual fact. The next pin 3 if you like, this one I'm sure is the one that goes to ground. This one, yeah. So the third pin in, that's ground. Okay, and the last one here is connected to VN via a 4.7k resistor light, so 4k7. So this basically just holds this pin high, so whatever is on VN is also on there. And I'm sure this is an enable pin, so effectively if you took this low, then the thing would shut down. So that's what we have. I mean, we can draw this a little bit better, to be quite honest. So we can draw it like this. So ground, that was pin 3, in was pin 1, out was pin 2, and then we have pin 4, which we can say is EN, enable active high, and that's connected 4.7k to there. So this is wired in such a way that that is always active high, unless there's something else that pulls this pin low. But I don't see it connected to anything other than the resistor. So if you had something else connecting from here, yeah, from this point, effectively connecting from here that can take it to ground, that could be disabled. But in our case, it's permanently enabled. It's just being used as a 3.3 volt regulator. That's what it should be doing. So why isn't it working? Well, I don't actually know, guys, but we have a capacitor to ground and we have a capacitor on the output to ground. I'm having one of those strange days when sometimes I draw ground like that and sometimes I draw it like a chassis. Never mind. They're all connected together, these points. Yeah? And two reasons why this wouldn't work. 3 reasons. 1, not enough input voltage. Okay. 2, something low resistance shorting the output or dragging the voltage down, but then this would get hot. 3, this capacitor, if it fails, then the regulator can't regulate properly, but it seems okay as far as I can tell so far. So let's have a look to see what voltage we've got on the input. Okay, let's see this. The input needs to be more than, I mean, I don't know for this device, I don't have a data sheet, but I think it's reasonable to expect that if the output is 3.3, the input should be at least about 4. Yeah, and probably a bit more than that. So we can try that. So let's have a look to see, first of all, if we've got enough voltage coming into our regulator. First thing then, do we have a short on the output or very low resistance? And I'm sure we don't because we measured it before. It's 305 ohms. That is fine as far as I'm concerned. Second one, is there a problem with a short on the power supply coming in? No, that's 6k. That's fine. Okay, so let's check some voltages. We know there's no short on the output or anything remotely like a short. So we go to chassis. So this is the output of that. I don't have a load connected to this, so if I switch it on, we have 3.3 volts. And then we have both ends of the resistor, this end and this end, and they're both reading 3.7 volts. So there isn't that much difference. There's only about 0.4 of a volt between the input and output, and that surprises me a little bit. Let's just switch it off. Just give it a couple of seconds for the capacitors to discharge a little bit, and then we'll plug it onto this PCB. Okay, we're on the PCB. Let's switch it on again. So we're back on. So what's happening with the input voltage now? So this resistor is the easiest way to get to it. That's now reading 2.7. What's on the other end? Probably the same, 2.7. And I'm sure that this point is the one that goes back, I think it's to this diode, that's 5. It's this one. So this diode only has 2.7 volts on it, which seems strange because this doesn't seem to be drawing much current. I've switched it off again. Let's just unplug it. So is this diode alright? I mean, the supply coming out of the diode, you'd think it was alright, wouldn't you? Is this capacitor alright? That's another good question. Let's go to diode mode. Okay, so yeah, I think there's a little bit of charge in the capacitors, but that's reading like a Schottky diode, 1.157. It reads the other way as well. That's just climbing up now. I can always take that diode out and just check it, to be honest. But I think that's okay. And that, I'm sure, goes to this capacitor. And I'm more inclined to think that the capacitor might have a problem here. So let's check that one. We can say fairly certainly that this obviously does go to here. It just turns upside down. This is the end of the diode. This is the capacitor. This is the one that we actually changed earlier, that one. But there's also this capacitor. And there's an inductor coil. So they kind of like, the two capacitors are either side of the inductor coil. I'll just show you on the bit of paper actually where they both are. One moment. The inductor coil is actually here. So from here there is an inductor coil. And then there's another capacitor here to ground. And then from here, this is where we have the rectifier diode, the Schottky rectifier diode. And this comes from the switch mode transformer. This thing, yeah. So that comes from a winding on the switch mode transformer, which I'm sure we'll find at the end of the winding goes to ground. So that's how we have it. This is the capacitor that we've changed, one of the two we've changed. And this one we haven't changed yet. This one is the one here. So it's possible if that capacitor isn't working, because we have an inductor here, this one effectively might not smooth it properly. Yeah, it's very likely you need this one to be working for this circuit to work properly. So let's take this capacitor out and let's see what it is and let's see how it measures. This one probably is a low ESR capacitor from where it is in the circuit on one of the output diodes of a switch mode power supply. So that does make quite a lot of sense to be low ESR. Now let's have a look on the capacitance meter. So it's 1000 microfarads. I'm on the 2000 microfarad range. So I'm going to have a capacitor and see how it reads. Well, it reads quite low actually. Yeah, that reads quite low. What's the ESR meter think of it? Okay, positive. Yeah, and you know it's not so bad. I mean, no, that's not very good. I mean, it's saying it's okay if it's less than 200, it's a 1000. Let me find another 10 volt or 16 volt 1000 microfarad and let's see what we can find that's low ESR and reads properly. These are some that I actually keep in stock. These are low ESR 1000 microfarad, 16 volts. So I often keep like a 16 volt rather than a 10 volt because, you know, you can use it to replace a 10 volt just the same. So we'll have that one. Let's see what these read comparison with the ESR. That was about 0.5. Well, this is reading 0.06. Yeah, so much lower, like a tenth of it. And let's check the capacitance as well as this one. So capacitance meter, let's see if it reads a nice healthy 1000 or more. Just bend that so I can just get at it and find the, yep, there's the probe. Okay, what's this reading? Well, yeah, it's reading a bit over 1000. Now this looks more likely to be bad enough to have caused the problem, the original one. I mean, that is reading quite bad, especially on the ESR. It doesn't look particularly bulged or anything, but I think that has a problem. I don't know why it's got a red line on, and just out of interest, this one's got a red line on as well. I haven't marked either of them. This is how it came to me. But let's check this, and we'll put this one in here, and let's then see once again if it actually works. So once again, there is our capacitor. I might be inclined to change this one as well, since it's the same type as the one I've just removed. But let's try it now and let's see what voltage we've got again on our 3.3 volt regulator. It's easy to measure on this resistor here. So I'll just fit the PCB and we'll get the test meter on and see what happens. I have this still disconnected first. I'm interested to see what input voltage is coming here, which I can now measure at the end of this diode, or I can measure at the end of the resistor quite easily. We'll plug this in. Okay, we plugged in. See what we've got. Well, do you know, it isn't really any better than it was before, 3.7. But I don't know what it should be, that's the problem. I don't know exactly what it should be. 3.7. What's on these other ones? 5. 20. 27. I mean, maybe that is correct for this regulator. Okay, so we have that, and we have coming out of it on the connector, still 3.3. What happens now if we connect this on? Does the voltage now stay, or does it drop? Let's have a look. So on there, we can switch this on. It looks the same on the front, so I think it made no difference. Oh no, 3.6 we have on here now. Does it come on? Yeah, it does come on. I've got a front display. Can you see? It's a bit odd to read, but it's actually powering up now. There we go again. Well, it did. Oh yeah, 035. I mean, first of all, that's very faint. And I've got a suspicion that I'm going to change a few more capacitors on here now. I think I'm going to change the other ones that look the same as the one, which is this one for certain. And these two look like they might be basically the same sort of capacitors as well. But it does at least give us a display on here now. Okay, let's change a few more capacitors. I have changed the other one, but to be quite honest, it read pretty good on the SR meter. Well, read like 0.1 or thereabouts. Read much better than that one that I took out. But anyway, let's switch it on. So we're on. Plug it in. Let's see what we get. So we do actually have on the front display like dashed lines. Standby light's just gone out on its own, I think. Little click. Yeah, it's come on. So the display reads very dim, but it does seem to be working. Yeah, I can change channel, but the display is just very dim. Yeah, I bet the camera hardly even picks it up. Well, let's just now connect this to my TV and see if it's actually working. Okay, so I've got it plugged in to my TV up here, and in fact you can see it is actually working. Just try and hold the thing a bit straight. It's all kind of encrypted in German, but we do have a picture. I do have a satellite dish here, but I don't have the remote control. Otherwise, I don't have a satellite dish on this particular satellite, but I could have sort of scanned in another one to see what we have. But that's looking good. I mean, I can like select different channels. It's just saying there's no signal, which is what you'd expect because I don't have a dish attached to it. So I think we're going to provisionally call that one fixed. Otherwise, I have to bring me the remote and I can scan in a different satellite. But I'm sure the voltages for the tuner will be fine, which is why I can see the sort of 22 and 30 volts. So there we have it, really. Turned out to be just one bad capacitor, but you know, rather than just changing it, we actually fault found. So there we have it, guys. It's working. I tried to scan in my satellite dish, which is actually on a different satellite to the one this is set for German TV. But it has a pin number on the installation menu. Somebody said a pin number. It may well be the standard one, all zeros on this, probably 0000, but I don't have a remote control, so I can't enter the number. Otherwise, I could use the menu and select button and the arrows on here to actually scan a satellite. But never mind, we do have a picture. It apparently would seem that this is now working, so I can give this back to Handy Andy and tell him to go and try it. Also, it'll be set up for this satellite as it already was. I hope you enjoyed that. I mean, I'm sure you could say, well, Rich, why don't you just change all the capacitors and you would have fixed it? And I think, yeah, you're right, I could have changed capacitors and that would have fixed it. But what we've done here is we've actually done some logical fault finding, and really should ask yourself, what do you want to be? Do you want to be a capacitor swapper, or do you want to be a diagnostic technician for electronics repair? Yeah, and if you want to be the first, yeah, change the capacitors and fairly often it'll fix it for you. If you want to be the technician who can diagnose faults, then keep on watching, and not only me, but I'm sure there's other guys out there who are doing the same sort of tuition that I'm trying to do at the moment. Anyway, regardless, I hope you enjoyed the video, whichever camp you are currently in or want to be in, and I will see you all soon on another Learn Electronics Repair video. Okay guys, ciao for now.